Welcome to the Army Oil Analysis Program, commonly referred to as the AOP. The purpose of this training tape is to familiarize new personnel and provide a refresher to our old hands on the overall AOP process for aeronautical equipment. This tape will cover the entire range of operations from taking an aeronautical sample through laboratory analysis to providing the lab with feedback on actions performed by your supporting maintenance organization. The AOP is part of a DoD-wide effort to detect impending equipment component failures through periodic analytical evaluation of oil samples. Oil analysis is a diagnostic tool to determine the internal condition of engines, gearboxes, transmissions, and other oil-lubricated systems and components. Just as the doctor checks your blood for disease, AOP laboratory technicians analyze your oil sample to tell what's going on inside your engine and transmission. Oil samples are analyzed for wear metals suspended in the oil. Wear metals are tiny metal particles of microscopic size, produced by the friction of moving parts within mechanical systems. The metal particles enter the oil stream and are uniformly dispersed and suspended throughout the lubricating oil system. Spectroscopy detects the kind and quantities of the different metallic particles in the sample. Analysis identifies the wear metal elements and aids in isolating the worn component. Through routine sampling and testing of the oil from the engine or transmission, abnormal wear can be detected. The worn parts can be repaired or replaced before they cause damage to the entire engine or transmission. What does AOP do for you? AOP will detect potential component failure, improve safety of flight, reduce maintenance costs through preventive maintenance prior to major repair, develop a data bank relating to component wear or failure. To sum up, the time it takes to draw an oil sample could save your life and your aircraft, or hours of maintenance downtime if the laboratory detects excessive amounts of wear metal or contaminants. Additionally, samples provide your commander with information about the condition of his equipment and the quality of his maintenance. You are the heart of AOP. The success of AOP at your installation rests upon your shoulders. Technical Bulletin 43-0106 is your Bible for aeronautical equipment in AOP. It provides you with information on your responsibilities as an equipment user and sample taker. Here's a short list of your AOP responsibilities. During the remaining portion of this tape, we'll tell you how these responsibilities are accomplished. Let's take a look at the sampling supplies your unit needs for aeronautical AOP sampling. Your unit monitor is to make sure that adequate sampling supplies are always on hand. Quantities of items stocked should be determined by the number and varieties of aircraft serviced and the frequency of sampling. The sampling bottle for your aeronautical sample is a 5-dram, 5/8 ounce pill bottle with a plastic screw cap. 1 gross is the unit of issue. The bottle is not reusable. The sampling tubes are polyethylene tubes which have been capped or sealed on both ends to prevent contamination. 3 sizes are presently utilized. All have 3/8 inch outside diameter. The 15-inch length is displayed. Tubes are issued in bags of 25. Tubing is not reusable. The plastic bag comes in a box of 250. This is a self-sealing plastic bag. The shipping sack also comes in a box of 250. The shipping sack and the plastic bag must be used when mailing the oil sample to your oil laboratory. When your supporting lab is located on your post, you can hand carry your samples to the lab. At the heart of your AOP role is knowing what to sample, when to sample, and how to sample. Your supporting oil laboratory, once it's equipped with the AOP standard data system, will have the capability of producing reports that will tell you what to sample and when it's to be sampled. Now let's demonstrate how samples are drawn. Your records tell you that it's time to do a routine sample on your Huey. Obtain a sample bottle and a sampling tube of the proper length for each component to be sampled. The tube method is used to take samples through the oil filler neck or through the dipstick hole. Samples obtained by this method are less likely to contain sludge and dirt than drain samples. Therefore, tubing samples should be taken whenever possible. Remove the filler cap or dipstick from the oil reservoir. Open the sample bottle and place the cap on a clean surface with the edges up to keep them clean. Cut the tubing if necessary and remove the protective end caps. Carefully insert the tubing into the oil reservoir. Do not allow the tube to touch the side or bottom of the oil tank when taking a sample through the filler neck, because sludge which enters the tubing can cause erroneous readings. Place a finger over the top of the tube, blocking the hole. Allow the tube to fill with oil, and withdraw the tube from the oil reservoir. The tube is then partially filled with oil. Insert the bottom of the tube into the open sample bottle, then release the oil by removing your finger from the top of the tube. Do not use mouth suction. Some oils are poisonous. Ingested or swallowed, the oil can cause major medical problems. Repeat the process if necessary until the oil sample bottle is filled to within 1/2 inch of the top. Then replace the cap back on the sample bottle and replace the tank filler cap or other access coverage. Discard the sampling tube. It is not reusable. And, of course, clean up any excess spillage of oil. The bottle should be marked to properly identify the component sampled and the aircraft number. Now let's demonstrate how to take a drain sample using the sampling tubing. Cut the tubing to desired length if necessary. In addition to the tubing, have a sample bottle and a cloth with you. Place a cloth around the plug area to absorb the seepage. Remove the magnetic plug and remove the plastic protective caps from the tubing. Displace the check valve with one end of the tubing, and the sample bottle goes under the other end of the tubing. Draw off enough oil through the tube to fill the bottle within 1/2 inch of the top. Then remove the tubing and cap the sample bottle. Then replace the magnetic plug and clean up any spillage necessary. Now you've drawn a routine sample, but it's not quite ready for submission to the lab. The next step is to fill out a DD Form 2026, Oil Analysis Request. This form must be filled out accurately and completely, and must accompany each sample to the lab.
The 2026 is an essential part of the operation. You should ensure that they are filled out properly. Some of our labs can get as many as 1,000 of these forms in a day, and it holds up the workflow considerably when we have to stop and correct unnecessary errors. Therefore, you should pay close attention to the next part of the tape.
Let's take a look at the 2026. In the to block, enter your oil laboratory address. In the from block, enter your MACOM, then your address and UIC. Next, the component sample, then the component serial number, end item model, end item serial number. These 4 entries are critical for management purposes, so let's take extra care to make sure that they are right. You may verify this information from the reports produced for you by your lab's standard data system. Next, enter the date you took the sample. The right portion of this block is not applicable to the Army. Next, enter the hours since overhaul and the hours since oil change. Check the reason for sample. Enter how much oil you've added since the last sample. The next 4 blocks are not applicable to the Army. Check how you took the sample, whether it's a hot or cold sample, and the type of oil. Use the remarks block for the purpose of entering any local data requirements. In addition to filling out the 2026, affix an identification label to the bottle and update your logbook. Once your 2026 is accurately filled out, it's time to send it and your sample to the lab. Wrap it around the oil sample bottle. Hand carry your sample and form to your lab the same day it is taken. If the lab is closed, simply use the drop box. If your supporting lab is not on post, slip the sample into the plastic bag. The purpose of the plastic bag is to keep oil off the 2026, and insert it into the shipping sack along with the 2026. Mail it first class to your oil analysis lab. At the oil laboratory, your 2026 will be date stamped and a sample number assigned. The lab technicians will perform a spectrometric analysis on your sample to determine wear metal concentrations. If the results are normal, the lab technician stamps your 2026 processed date and the results normal. The 2026 is returned to you. When the completed 2026 is received at your unit, file it with your records. And discard the previous 2026 for this component. The cycle is complete. If the results are abnormal, the 2026 is stamped abnormal. Submit a special sample. The request for a resample or a special sample should not be considered as a basis for removal of a component or as an indication that the aircraft is in any danger unless the lab specifically states that it is. If the lab recommends removal of an item from service, you must take the lab's advice. The oil laboratory telephones the results to your unit oil monitor for compliance. The original 2026 is returned to your unit through normal channels. Get that special sample back to the lab ASAP. Upon complying with the lab's recommendations, fill out a new 2026, marked Special in the Remarks section, and mark the border red. Check Lab Request for reason for sample. The new sample checks out okay. The oil lab calls you and returns the 2026 through normal channels. When you receive it, update your records and file this 2026. What if abnormal findings require maintenance actions?
Hello, Sergeant Thomas. This is Mr. Yarber at Fort Campbell Oil Analysis Lab. I'm calling in reference to your aircraft 124, the engine. We have confirmed that you have a problem with iron on this engine. So I'm going to recommend that you ground the aircraft and remove this component and send to the depot for teardown analysis. And your 3254R will follow. Thank you. See you later. Goodbye.
A Twix will be sent to units not located on the same post as the lab. The unit maintenance officer will immediately remove the item in question from service. The corrective action for all recommended maintenance services listed on the DA Form 3254R, Block 9, needs to be accomplished as soon as possible. If Aviation Unit Maintenance, AVM, performs the maintenance action, then AVM completes Block 14, Feedback, with a detailed explanation of what was done. The 3254R is returned to your lab attached to a completed Standard Form 368 Quality Deficiency Report. If the oil lab recommendation requires higher level maintenance action, the AVM initiates a DA Form 2407, attaches the DA Form 3254R, and the Quality Deficiency Report, and evacuates the item to a higher level maintenance facility. Higher level maintenance will provide the final feedback to the lab. Why is feedback so important? First, it provides an indicator on how well the laboratories are performing. Your feedback tells the lab whether they were right or wrong on their recommendations. Second, AOP management can adjust the evaluation criteria that it uses in making lab recommendations. Lab recommendation accuracy is improved. Third, your feedback is important to the equipment proponent who uses the information to isolate patterns of equipment problems. Finally, for items showing an abnormally high failure rate, feedback may provide clues that can be used to affect a design change. We've covered a lot in this short tape, so let's go over a few of the important things to remember. Know when your equipment is to be sampled. Have the right inventory of supplies. Always draw a reliable oil sample. Observe all necessary safety precautions. Don't contaminate your sampling supplies or sample. Fill out your 2026 clearly and correctly. Resample when required. Mark the 2026 special. Get the sample back to the lab in the prescribed time. Use the 3254R to keep the lab informed of all maintenance actions. Stay familiar with Technical Bulletin 430106, Aeronautical AOP. AOP is an effective maintenance diagnostic tool and not a maintenance substitute. AOPE does not minimize in any way the need to employ good maintenance practice and strong maintenance discipline. The success and effectiveness of AOPE is dependent upon the testing and analysis of reliable oil samples and good feedback. It's your program. Do a good job.